All right, folks, this is very much take two for me, and thank you to those who pointed out that the audio wasn't really working in the previous one. My apologies for that. So I'll re-upload this and see how it works. Um, so what we're looking at today is something slightly different. This is a virtual oscilloscope. Now, an oscilloscope is a device which we use to look at sound waves. You'll be aware from our lessons that sound waves are involved in hearing, so there are things that we can sense with our ears. However, what we're doing just now is we're creating an image of sound waves. And you can see that the screen is responding to my voice. So I've got a microphone here, and you can do this with anything, any kind of noise, clapping your hand, for example. Okay, there's a little delay, you can see the processing time. We're taking that sound energy, turning it into an electrical signal, and then in this case displaying it as light. And that's what the microphone does. The microphone takes sound and turns it into electricity that you can then listen to via a loudspeaker. So the reason I'm using this is because I want to display a few things about sound waves, and I think this is the best way of doing it. We're interested in two different types, two different elements of sound. One of them is pitch, and one of them is volume. And I'm going to talk you through those via the oscilloscope that I've got in front of me, and absolutely once you've finished this, you can have a play with this as well. Now you'll notice if I just, I'm looking at this thing and I freeze it just now, whenever we look at sounds which are produced by our voices, for example, or clapping our hands, or even some instruments, you'll notice that they're not very nice. We have this kind of jaggedy effect where we've got bits that look like peaks, they're very inconsistent. And the reason for this is because sound waves are actually created by, sounds generally are created by the addition of multiple pure sounds. So this is, if you like, an impure signal. You can see that has that characteristic shape, like I say, a peak and a trough, a compression, a rarefaction, but they're not very clean. And in order to really talk about pitch and volume, we have to really produce a clean sound. Now, one way of doing that is by whistling. I have spent a long time doing this as a physics teacher, and so I'm usually able to do it. So let's just give it a go and we'll have a look. So first try. Okay, pretty happy with that one. What you can see here is we've got a much cleaner sound. It's still not perfect, it's not ideal, but hopefully you can see that this is sound with more peaks, more troughs. It's very clearly defined. We've got peak, trough, and remember our peaks are corresponding to compressions, those areas of high density, and our troughs are corresponding to our rarefactions. Now let's just have a little look at this. We've got, let's just pretend we can see a crest here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 crests. Okay. Now what we're going to do is we're going to compare this sound to another sound and see what this is, the difference. So I'm going to try and whistle a different pitch this time, and we'll see what that looks like. Okay, hopefully you can see here, we went from 14 and we've gone 1, 2, 3, 4, 5, 6, 7, 8, 9. Fewer peaks. What this means is I've lowered the pitch, I have lowered the frequency. Frequency is a measure of how many waves are passing every second. So a frequency of 10 hertz means we've got 10 waves every second. A frequency of 5 hertz, 5 waves every second. In this case, don't worry about the actual value. We could calculate that using the time here. We won't worry so much right now. All you can see there is that by having fewer peaks, we've got a lower frequency. So I whistled, okay, and I'll just sort of show it just now. We're going from high frequency to low frequency, high pitch to low pitch. So hopefully we're picking up now that our frequency of our sound waves is processed in different ways by our ears. So if you have a high frequency, you have a high pitch, low frequency, low pitch. I think I've repeated that a few times. Something else that we can change is the volume. And the volume is all about the energy stored in that wave. And just have a think to yourself, what might be linked to the volume? What feature might be linked to the volume? Well, let's try it. For this case, it's going to be quite hard for me to do this, so I'm going to try my best here, and I'm definitely going to fail, but we'll just give it a go. Nothing ventured, nothing gained. I'm going to try and whistle a loud sound, and then I'm going to try and whistle a quiet sound, but with the same frequency. So I'm going to go, hang on, sorry, it's hard for me to do that. It's really hard. I don't know why I'm having trouble here. Okay, that'll do. Okay, So that's I'm going to call that the loud sound. It's not particularly loud, but that'll do. Just take a note of that shape, and I'm going to try and whistle it quieter. Hopefully you notice there, again, there's a bit of a shift there. We've got roughly the same frequency, okay? I think I changed my frequency a little bit, but one thing you'll notice there is that the size has changed. The size of a wave, we're looking at the vertical size here, you'll know is the amplitude. When we change the amplitude of a wave, of a sound wave, we change its volume. In other words, the more energy, the more amplitude, the more sound we're going to get, the higher the volume. Now, this is where your knowledge of everyday terms might come in if you know about amplifiers. An amplifier, I can show you here what an amplifier does. An amplifier is a device which allows you to turn up the volume. So let's imagine I was listening to this sound and I wasn't happy with it. What I could do is use the amplifier to make it to be a bigger sound. Okay, and a bigger, I mean a bigger height, a larger amplitude. I could also make it lower to zero. Right? I could make it into a zero sound, or I could go somewhere in between. The amplitude controls the volume. So if you're listening to loud sounds, those are high amplitude. If you are listening to quiet sounds, those are low amplitude. So if your teacher asks you to be quiet, then they might say to you, lower your amplitude. What that would require is you to stop talking and to reduce the noise. And I'm sure that none of you have ever been told that ever. Okay, so in our next lesson, we are going to be talking about this. So you just need to have those key ideas down, that if we change frequency, we're changing pitch. And if we change amplitude, we're changing volume. In both cases, the higher the frequency, the higher the pitch, the higher the amplitude, the higher the volume. Okay, I hope the sound has worked this time. My apologies it didn't last time. We'll talk about this more in detail next lesson.